before we write a single line of SQL, we should have a good idea of exactly what we want to do with our database and what our database should look like by the time we've finished creating it. We should go through a process of planning or data modeling before we start implementing our solution. The question, where do we start when we're about to create a database solution for a particular problem, is best answered that we should first of all understand the nature of the problem. We should look first to the real world needs or problems that have created the need for the database. Sometimes it'll be just us who needs to use the database, and therefore it's simply a matter of getting our thoughts together on paper or in our heads or however we wish to do it. More likely though, we'll be designing a database for a number of people, all of whom have an idea about what they want to get out of the database, and this could be such a diverse range of people as the head of the organization, the programmer who is going to interface with our database, the end user, the person who is going to provide technical support to the end user, the customer, and so on. So it's important that we consult everyone involved and get a good idea of what their opinions are as to the needs that underpin the creation of the database. It's important that we analyze the problems that underlie the needs for creating the database in the first place, and that we have a set of objectives that everyone has agreed upon and that we can go forward to implement. Once we've done our consultation and we've talked to all the relevant people, or if it's a very small project just involving, say, yourself or you and one other person, had a chat or even just sat down and had a think about it, it's time to start getting a little more concrete about the way in which we want our database to be structured. I like to start putting things down on paper from the earliest opportunity. And this doesn't have to be in a very structured way at all. I like to use a simple brainstorm, just a scribbling on a piece of paper, to get some ideas down as to what I think I need to include within my database. There's no particular logical right place to start here, just want to get as many ideas down on the paper. I'm taking as an example the library database that we looked at in the last movie, and how I came to come up with that particular set of tables. I knew that I wanted to center the library database around the books that contained within it, so I wrote the word book on a piece of paper, and then I simply drew lines out from that central point with all the other relevant elements I thought should be present within the database. Of course, this is going to be a very scrappy process, one which you may bring up at least as many questions as the answers. That's the whole idea behind a brainstorm. You may find that you add elements which you later realize that you don't need to include at all. That's all fine. Part of the process is making the mistakes early so that you don't make them once you've implemented within your database, and then you have to worry about programming, taking data from one place to another, and all these other kind of hassles and nightmares. It's much better to make the mistakes on the drawing board and get them all ironed out as much as possible before you go to implement your solution. After we've got a general idea of the kind of things that we want to be doing in a brainstorm or however you like to do it, it's a good idea to map out the concept behind whatever application you're using for your database, or for your database structure for that matter. You may need to create a few of these to make concrete some of the ideas of what you're wanting to do with your database system. For instance, this one is a simple diagram that illustrates the way in which I want to run a search query on the data. I want to be able to search by title, author, ISBN or publisher, and I want it all to have the same result and come back as the results of my query. So a simple diagram, even as simple as this, will help to solidify in your mind exactly what you want to be doing. It's at this point that you can start getting technical, by which I don't even mean writing any SQL yet. I'm still several stages away from that. Now it'd be a good idea to create an entity relationship diagram. The idea of entities is a common one across various different disciplines within programming and software design. If you've done any programming before, you'll be aware of the object paradigm and the structures of object-oriented programming. With a relational database management system, our entities are rather different to the objects within object-oriented programming languages. However, they do have some similarities. Each of the objects should be a single item within our database, and we should try to stick as closely as possible to real-world entities. For instance, we may wish to create an entity called a book, and in general, our entities within our entity relationship diagram will translate directly to tables within our database. There are some specific ways to create an entity relationship diagram. Some ways of drawing lines to represent the relationships between entities. You can follow these if you wish, or you can use your own method. It doesn't really matter. So long as you understand and you're consistent about the way you're laying out your diagram, that's the main thing. Most important thing about entity relationship diagrams is that all entities that are going to be included within your database are mapped out in your diagram. For instance, we may have a book entity and a publisher entity. We also need to specify the exact way in which they relate to each other. We draw lines between each of the entities that relate to each other, and then in some way we annotate these lines to show the particular kind of relationship it is. It's usual to put a crow's foot or extra little lines there if we want to show a one-to-many relationship. If it's a one-to-one relationship, we simply put a single line. We can also use a circle to indicate that the relationship is optional on the part of one or other of the entities. That is to say, a publisher can exist within our database that hasn't published any books yet. This allows for all kinds of different theoretical eventualities. We put the circle on the side of the book because the publisher can exist without the book, but no book could exist without a publisher. Similarly, we put in a genre entity within our entity relationship diagram. However, there's a slight difference here because genres can exist for which we have not yet entered books into our database, but we can have books that defy genre, books that refuse classification. Therefore, I'm including a little circle there to show that it's optional at both sides of the relationship. However, it's still the same kind of one-to-many relationship. One genre, many books. We could go further and complicate that to say that a book can cross between two genres, but I think that's better exemplified by the author entity. Now, we could simply put a one-to-many relationship there or between books and authors, but that would only allow books to be written by one author. Now, that is not a rule that we can impose on our library, especially if we're going to be using technical or non-fiction books, many of which are written by more than one author. In order to represent a many-to-many relationship, as in any number of books can be written by more than one author, we have to use a bridging table. I've called this book author, and this is a way of implementing a many-to-many relationship in a way that can be used by our relational database management system. If you take a look at the SQL schema that is included in the source folder on this CD, you'll be able to find the particular tables that are included within this database. Finally, once you've made your entity relationship diagram and you're happy with the way it looks, then you can start to draw up your SQL schema. You'll find that as you implement each of these steps, as you draw out more and more technical diagrams and finally create the SQL, you'll find that you'll be constantly refining as you go. So you may draw up a first initial draft of your SQL schema, and then you may find that you will refine it, create different tables, alter the structure of your database, and so on. This briefly sums up the process by which we get from the conceptual point of the process to the actualizing of the database. In the next movie, we're going to look at normalization.